Hi everyone, we're going to find the intervals of increase or decrease, find the local max and minimum values, find the intervals of concavity and the inflection points, and use the information to just sketch the graph. The sketch is just a rough little sketch. All right, so to find the intervals of increase or decrease, we're going to take our first derivative. So f prime of x equals 24, doing this one, x squared plus 4x cubed. And then you set that to 0, but let's factor this some more. Factor out a 4x squared, and you're going to get a 6 minus x, and then set that to 0. So we have x equals 0 for this piece, and oh, this is a plus, and x equals negative 6. So we're going to find our intervals of increase and decrease. So let's do a little sign diagram. Write negative 6 to 0 and see where our interval is increasing and decreasing. This is your x line. We want to know what's going on in between these intervals. Okay, so we're going to just test some values. If we plug in, let's say, negative 7 on this side, a number less than negative 6, this is going to be positive, this is going to be negative. So this is going to be negative, which means it's decreasing on this interval from negative infinity to negative 6. All right, and now let's plug in, say, negative 1. If I plug in negative 1, I'm going to get a positive again. And then this is going to be a positive. So this is going to be positive. That means the interval is increasing from negative 6 to 0. Also, let's see, this one. Let's plug in 1, and it's also positive. So since both of these are positive, we can just say it's increasing with x is greater than negative 6. Because both of these are increasing. Or you could say negative 6 to infinity. It's increasing. So this is increasing. All right. Now basically, if you have it's something like this, you're decreasing here, and then all of a sudden you're increasing, and then you're increasing some more. All right. So now let's look at what we only have a local minimum at negative 6. So at negative 6, we have f of negative 6 equals negative 32. So that's, I already did the math for you, so we didn't have to do that. You just plug negative 6 into this, and you're going to get negative 232. So that's a minimum value. All right, and we don't have anything at 0. So basically, we have x has to be greater than negative 6, but x can't be 0. It can't be 0 because if you plug in 0 in this, you get 0 equals 0. And so that just means you have a horizontal tangent. So no max value. And you have a horizontal tangent at x equals 0. If you plug in 0 in here, that's going to occur at 0, 200. So we'll be plotting this point, and we'll also be plotting this point as your minimum value, negative 6, negative 232. So those are the two things we have. Now we're going to take the second derivative. I'm going to go ahead and do it on this. Let's look at this. The second derivative would be 48. So f double prime of x equals 48x plus 12x squared. So I just wanted to do that so I don't have to copy that again. So let me write it on here. Our second derivative, So this is G, I did it as F. So F prime of X equals 48X plus 12X squared. Now let's factor that. Factor out of 12X. And you're going to get 4 plus X. So we have set this to 0, and we're going to get X equals negative 4, and X equals 0. Now in the second derivative test, you're testing for concavity to see if we're not testing intervals for increasing, decreasing. We're testing if it's concave up. So this is like a concave up. This is like a concave down because it's going kind of downish like that. So let's do a number line here. So we're going to go to negative 4 and 0. So what's happening when x is less than negative 4, when x is greater than 0, and when x is in between negative 4 and 0. So if I plug in, we'll just use this one, it's easier. Plug in negative 5, this is going to be negative, negative. So two negatives make a positive. Let's go ahead and plug in 1. If I plug in 1, I'm going to get positive and positive. Two positives make a positive. Now let's plug in negative 1. If I plug in negative 1, this is going to be negative, but this is going to be positive. So a positive times a negative is going to be negative. So this means concave up. This one is concave down. This one's concave up. Now, that's all you need to know on that. So our 2 points are here, because we're going to use that for graphing. So at negative 4, we have CD concave down on negative 4, comma 0 here, and concave up on negative infinity to negative 4, and 0 to infinity. And so let's do our inflection points, and you just plug in these 2 points. We want f of negative 4 and f of 0. So f of negative 4 is negative 56. F of 0, we already did that. That was our horizontal tangent, and that's going to be 200. So we have an additional point here at negative 4 and negative 56. And we already have our horizontal tangent at 0, 200. Okay, so now the way we graph it, I already did the graph for you. So this was our minimum value. These two were our inflection points. Remember, we were going from concave up and concave down. So we started at negative 6 here. This is our negative 6. And this is going to be concave up. Remember, this was concave up from negative 6 to negative 4. So it has a little bit of a upward thing. Now, from negative 4 to 0, put the 0 there, put the negative 4 there, it's concave down. So that means it's still going up, it's still increasing, but it's kind of leaning down there, leaning down. And then from 0 to infinity, we were a little bit concave up like that. I'm exaggerating a little bit. Now this is just supposed to be a sketch. I have it on a grid because I'm working on an iPad. So, but usually when they say sketch, there should be no grid. Now your horizontal tangent occurs right here. There's your horizontal tangent. All right, and that's it. Thank you. Have a nice day. Bye-bye.